Okay, now let's look at the sample solution of the inheritance problem, inheritance exercise. Here we have at first the interface as before, nothing changed here. This is the same code, but what's new is we have a class vehicle. Oh, I'm sorry, that was a click too much here. We have a class vehicle that the class definition, we say create is protected. So there's some other things that I can explain in a minute here, but first of all we say the vehicle implements the interface, and it has the data that we had before in the class in the car that is like common for everybody that we want to kind of combine in a shared code class in the vehicle. Now create protected means that create object is only allowed in this class or subclasses. It's kind of like create private, except that a subclass can also create instances. It's not important in this case. Abstract is more important in that it means that you cannot create an instance of LCL vehicle. So in the definition here of the class, we say we consider this class incomplete, and you have to subclass to be able to be able to use it. And why? Well, because maybe, for instance, we do not implement all the methods. So let's look at the implementation of vehicle. We have refuel, drive distance, and get current tank level. We have the refuel method here, the same code that we had before, the drive distance, same code, and tank level, same code. So the implementation is complete, but still we say it's abstract. Now this is not needed, but you can add it and say basically we don't want this class to be used directly, but you expect people or yourself to really use subclasses from this when you create instances, and only use this kind of like a superclass where you put shared code. So now we come to the car definition, and remember we have vehicle now. It's number one. Vehicle, the interface we have, and now comes car and truck. So we have the car definition, create private. We have the get instance method still, inheriting from the superclass. This is new. So we say we inherit from the vehicle superclass, which means we kind of import everything from the definition, and also including the code is the implementation from the superclass. But in this, we have new methods, new elements as well. In this case, the get instance. This is something that exists only here. And because we need the table, the instance management table, we also define this here. So we have the instance table and the local type. So logically, you can say the car adds instance management to the abstract class of vehicle, the abstract definition. And the implementation here is basically only get instance. Why? Because all the implementation and all the everything that's needed, for the LCL car comes down from the vehicle. So the only thing we defined here that we need to really implement is get instance, and everything else is inherited. So even though I have only one method implemented here, in reality, when I use car, I can use everything that is defined in the public section. That is here, of the vehicle. And since I have nothing there except the interface of the vehicle, I have everything that's defined in the interface. So refuel, drive distance, get current tank level. And I have to access it using an interface reference. So that is the car implementation, one method. Now I have a truck. Truck I do simpler. I just have create public, no trouble with inheritance, with instance management. And again I say interface, inheriting from LCL vehicle. So again I get everything inherited from the vehicle class, but I add something else. In this case I add a constructor, and I want to redefine the refuel method. So what do I do in the constructor? Well, first of all, I want to call the super constructor. I mentioned earlier super is the reference on how to call the superclass methods, and this means I call the constructor of the superclass. If it doesn't exist, it doesn't hurt, but if you add it later, it is called. So implicitly, when you don't specify a constructor in the system, it kind of gives you a default empty constructor, so you can always do this. But basically, it means whatever the vehicle wants to do to initialize, you can do that in the constructor there. And for the truck, I want to say, in this case, the fixed capacity of 1,500 liters and the fuel consumption. Actually, a pretty good truck for 12 liters per kilometer. That is basically the same code we had before in the truck. And for the refuel, we can refuel the main tank here. Now, I mentioned it, we really have to do also something else. We wanted to have a reserve tank, or a secondary tank or something like that. This is not implemented here. I wanted to not show everything, but it's very simple. Basically, how would you do it? You would add a definition, you would add data element here of another tank. You would have a get tank level maybe, but you really don't, actually that is missing, the get tank level. And you want to then, of course, change the refuel method. So this is coding that is missing here. How would you use this stuff? We have, it's similar to the last exercise. We have a vehicles to refuel table with interface references to the, using the LAF vehicle. So interface references to whatever vehicles we want to refuel. We create an instance here of a VW Golf that is an LCL car. So here I'm creating car as a subclass of vehicle, right? And so I have vehicle to refuel. I have a car reference. Implicitly, I could basically change it to a vehicle reference, but I can also change it to an LIF, so an interface vehicle reference. So I meant LCL, the class vehicle, I could also do, but I immediately cast it to a interface. So I talk to the car using this interface reference here. And same thing with the truck. I create a truck. I use the interface reference and add it to the table. And this is the same thing. I have the same client code. I refuel all the ones that I have in the list here. In this case, just the VW Golf and the truck. And I would do it just an assert to make sure that this really worked. So again, the point is the client code is the same, but we changed quite a bit. We put a vehicle class in between. We moved the shared code up to that class. And we have two subclasses, the car and the truck, that are really derived from the vehicle, and they can do different things. And you can do, of course, you can imagine you can add all kinds of things here, additional data and methods to do whatever is necessary to implement your truck, your specialization. Now, to give you a better idea of what really happens, it's useful to look at this in the debugger to see how things really behave. And let's do that. I put a breakpoint here. And let's start this program. So switch again to this view here. Okay, so we're in the main program now. We are at the first place where we want to create an instance. And what happens when I create an instance, of course, is I first get into the getInstance method. I look, is this thing there already? No, it is not. That's why I have to create an instance, get it. I set the variables, the values, the attributes of this instance, put it into the table. I'm done here. Okay, and I append the vehicle to refuel to the table. All right, now I want to show you some interesting things. Vehicle to refuel. That is the variable here. We see a value, but the type is interesting. We see that the type is ref2LIF vehicles. So it knows this is an interface type, but the value is this one. If I double click on this, I see I have actually an object of type LCL vehicle, and these are the attributes. This is the data inside. And now I see something interesting even. I have the superclass vehicle here, and it shows me the car is a subclass, and it has the instance table, remember this class data, as an additional attribute. So you can see even the object, so you see the object in here, and you see the whole object inheritance. You see also here something called object. We didn't define that, but implicitly all objects, all classes rather, inherit from the generic class object, and it has a few things on it that are that we won't talk about now, but that are also interesting. So basically, you can see here the class car and which elements data in this case, comes from the car level, from the vehicle level. And these things is the visibility. This means protected, yellow, and red means private, green means public. So that is a good way to see. So I want to go back to this. Okay, so we showed how a vehicle to refuel, this is a reference to the object, the right object is in there, was created. Now if I do the same with the truck, create object to the truck, there I'm the truck constructor at the create object. The super constructor didn't do anything, that's why this doesn't even show anything in the debugger. I set the tank capacity, full consumption, come back. Now the create object statement is done. Again, I have vehicle to refuel is set, and now if I double click on this, I see I have a vehicle, but I have a truck. So I see here what is really the type of my real object, and you can also look at this here in the sense it has a very long name, but basically it shows you, because it's a local class, it's LCL truck, that's the name, but where does it live? It lives in the program, ABAP, ABAP ASEO intro, and so forth. So this whole name, this long name, basically is the global unique identifier of this class, because it's the program, and the class is a sub-element of that, so because the name by itself wouldn't be clear enough and unique. So again, you see here it's a truck, subclass of vehicle, and it's easy then to debug and see what are the values, is it correct or not. So I go add these, I have added them to the table. Now I loop at the table, and now I want to show what happens when I call the refuel. The first object was the VW Golf, and I see that immediately I call the refuel, I'm in the vehicle implementation. Why? Because the refuel method was inherited from the vehicle, and now the refuel method was defined by the interface. So actually I have this name as the method that I'm really working in, but the implementation is here on the vehicle level, and I just step through it and I'm done with it. So that was the VW Golf, I believe that was, and now let's go and look at what happens with the truck. Now I am, again, I see LIF vehicle refuel, but where am I? I am in the truck implementation. So I see now I didn't go to the refuel of the vehicle, but I am in the truck class. Why? Because I said I want to redefine this refuel method. And now I call super refuel. So first I call the refuel method of the vehicle class, which is the super class, step through this and come back. So normally I would do additional things like fill up the reserve tank. I didn't show this here, but this is how that works. So if you think about the control flow, it can be a little tricky with objects because you go up and down, so to speak, in the class hierarchy. So it's sometimes not so easy to follow. It takes a little bit in getting used to it. But again, this is then the end of it, and then the rest is just the standard behavior of the program. Everything's fine. All the asserts are fine. So we looked at the sample solution. We looked at the objects in the debugger. There's one more thing I want to discuss, and that is similar to the interfaces topic, some final thoughts that are, I think, better to understand now that we have seen the example. And this has to do with polymorphism, how to implement it. We've seen interfaces and we've seen inheritance. And in some ways they are similar because you can basically access classes through so many different classes through the same interface. So you basically deal with different classes in a uniform way through the interface. What you can also do, which we didn't really show in the example, is if you, say, have a superclass and it's not abstract, and you can have, or even if it is abstract, you have many subclasses, but you talk to all these classes through the interface type of the superclass. Basically, you call refuel, and if the subclass redefined the method, it will be called. Otherwise, you call the superclass. So each class can decide what it needs to redefine, and you talk to all these classes in a generic way by addressing them through the superclass interface. So for instance, if you have a vehicle, in this case you have a vehicle reference, and a whole bunch of subclasses. You could do the same loop that we have with the interface now. You could also do it with a reference to LCL vehicle, meaning you talk to the superclass, and you could do the same things. You could call the refuel method and so forth. If it was redefined, it would go down and so forth. So you have two different mechanisms of abstraction, and they have pros and cons, and this is what this slide is about. So inheritance is a very strong coupling between the classes, and you also saw it in the debugger. It goes up and down quite a bit. It's complicated in the control flow, and so you shouldn't use it just as a convenient means to share implementation code. Why? Because a subclass must do the same or more as the superclass. This is the so-called substitution principle, and basically what's behind this is that the behavior promises by the interface of a class C or the superclass must be satisfied by all of its component subtypes. So, for instance, let's think of squares and rectangles. You would think, oh, square, is it a subclass of rectangle? You would think maybe intuitively, yes, of course, because it's a subset, but subset is not a subclass. Why? Because let's assume the rectangle has methods to set A and B, set both sides of the rectangle. Now the square has only one data it needs to remember, and it can only set one side, and it has to be both the same. So if you now try to call, let's say square would be a subclass of rectangle. Rectangle has the method set AB, and square has also the method set AB. But in the square, of course, when you try to set AB differently, then it doesn't work, because the square is supposed to be a square, which it means A has to be equal to B. So the rectangle kind of makes the promise that you can set A and B differently by the definition of its interface, by the superclass. Rectangle has two different methods for set A and set B. But the square, if you would do it a subclass and you imply some kind of constraint, then it is not a valid subclass. Because if you address subclasses generically through a superclass interface, you want to be able to deal with all the subclasses in a generic way, and which means that you are able to change, set A and B independently. Or another example is, for instance, if you say red car, is it a subclass of car? It is a subset, yes, but if the car is red and the set color method gives an exception because you say, no, this is a red car, I don't want to change the color, then if the superclass has a set color method, it is not a subclass, it's just a subset. So this is kind of confusing, but it is important to get right. And this substitution principle is very important to keep in mind when doing inheritance, but it applies even in a similar way to interfaces, except there you don't have this subclass and superclass kind of thing. You just have an interface and you say all classes must behave the same as the interface specifies it. But if you think about the superclass as the interface, all the subclasses must logically behave as what the superclass promises. And so sometimes, since it's so intuitively, you think about subset, and really what you need to think about is subclass. So important rule, a subclass must do the same or more as the parent, but not less. So then there are two different ways, if you think about how to reuse code. There is delegation and inheritance. If you look at those pictures at the bottom, inheritance is what we just saw. We have a vehicle class and we have a car and a truck as subclasses. And now this means, again, this has to do with you use all the subclasses through the generic interface of the C parent class, in this case the vehicle. So you would utilize the inheritance you have here by some code that talks generically to on the C parent level, and the subclasses are the implementations. And so if one subclass can do something special, that's okay, and the parent doesn't have to know, and the client code doesn't have to know. But if you want to use reuse some code, this is one of the reasons maybe why you moved that there. Still, this gives you a very tight coupling between them, and you can also only have one parent. Another concept is delegation, and so if you have the subclass S1 and S2, you can say, well, I want to reuse code, but I don't want to necessarily inherit from a common superclass, because, for instance, maybe I have two classes I want to inherit from. So CNE1 and CNE2 that I want to use for my implementation, and I can't inherit from two. That has a lot of problems. That's why we didn't include it in ABAP objects. So delegation means there is a class S1, but really the implementation is delegated, of some part of it at least, to another class, and that's behind the scenes. So the public interface will show the S1 public interface of the class, but the implementation is delegated to something else. And this is another way to reuse code, but this is more flexible. One important way why this is more flexible is the coupling is not as strong between, so there's no callback and up and down in hierarchies. And the other thing is that you can have basically not multiple inheritance, but multiple delegations. So for instance, let's assume you have a business objects, a whole bunch of them, and you want to have archiving features, and you want to have database, some features that have to do with participating in database commit protocols, and maybe something that has to do with UI. So all three of them are probably three different interfaces that the classes have to implement, and you can delegate. If you use inheritance, it's really hard to think about to put all the code in a parent class, because you get lots of collisions, logically collisions, so to speak. And in the delegation case, you can have basically a thin class of the object, and they can delegate to archiving, delegate to some commit manager, controller, or whatever. So the different aspects, you can combine many things much more easily. So maybe this sounds very abstract to you. Initially, it probably definitely is the case. When you get a little more used to programming in objects and you get a feeling for the problems of the dependencies and the different kinds, it's worth to come back to this. And this is also where the pattern books that we mentioned earlier are very useful, because the patterns are about standard solutions to always recurring problems. And so I highly recommend that after you get your feet wet with objects on the technical side, you look at a pattern book and learn how to think about these kind of things in a better way, and give you sample solutions where the pros and cons are clearly defined. Okay, this is really the end of the ABAP Objects refresher course. Here at the very end you have the slides as well. There is a syntax summary, but that probably doesn't concern you right now. Thanks for listening. I hope it helps you to get started in a practical way, and that you are then prepared for the Agile Software Engineering course in ABAP.